Hello, linear algebra student. This video is for chapter 1.5, part 1. We're going to look at how to write the general solution of a system that has multiple solutions, but write it in not like an equation form, but in vector form. So that's the main goal of 1.5. We already know how to solve, solution that has infinite solution, system that has infinite solution in like a whole, like a column form of x1 equal to something, x2 equal to something. But we want to convert it into a vector form and also understand what it means by what it means when it is in vector form. Understand the geometric implication of it. Secondly, we're going to introduce such a new term called homogeneous system. And we're going to understand how a homogeneous system is different from the non-homogeneous system in terms of the solution and also the relationship between their solution. So what is a homogeneous system? By definition, a homogeneous system is one where the ax equal to b side, the b is a zero vector. That means you're solving ax equal to 0. And it would be a very easy solution equation to solve because one of the equation must be 0, right? If you think of for any matrix A, you plug in 0, 0, 0, 0 here, you always get 0, right? If you don't combine anything, column vector, it becomes 0. So there is always a solution, and we call that solution a trivial solution for the homogeneous system. But for some system, there would be a non-trivial solution. Other than 0, 0, 0, maybe it is infinite solution. So we want to solve it and also write it in a different form. So first of all, recognize which one of these four is a homogeneous system. This one is not because on the right-hand side is a 1, right? This one is because the right-hand side B is 0, 0, and this one is also, okay? Assuming all your x's on one side, right? And then which one is has non-trivial solution? So non-trivial solution are the one where it has some free variable, right? If there's no free variable, then your only solution will be the 0, 0, 0 solution. So let's enter these into a reduced row echelon form. -5, 7, 9, 0, 1, -2, 6, 0. -5, 7, 9, 0, 1, -2, 6, 0. I enter it. So I'm going to do a reduced row echelon for B. And it's 1, 0, -20, 0, 0, 1, -13, 0. So I would say, so it is 1, 0, -20, 0, 0, 1, -13, 0. So obviously it has two prefix column and this is non-prefix, so this is a free variable, right? So this would has non-trivial solution. What about this one? 1, 2, 6, -2, 5. I think I enter it somewhere. 1 here. 1, 2, 6, 0, -2, 5, 0, -5, 0, 6, 0. So that's G, right? So I do a reduced echelon for G. And you can see that it is just 0, 0, 0, 1, 0, 0, 0 like that. So there is no free column. So this become a 1, 2, 6, 0, -2, 5, 0, 0, -5, 0, 6, 0. And after you reduce it, is 1, 0, 0, 0, 1, 0, 0, 0, 0. Okay, 1. So here, no free column, no free variable. So no non-trivial. No non-trivial. So the only solution is 0, 0, 0. So that's how you discover it. You look at if there is any non-trivial column. So how do I write parametric vector form? So in the past we have our way of writing it would be like this, right? It's kind of like x1 equal to what, x2 equal to what, x3 equal to what, all the way. And then if it's free, we would say free. If it is constant, add something, we'll do that. But this is called a vector form. The vector form basically say if there is a free variable, we actually pull it out and write the coefficient as a vector. And if there is a constant vector, we write a constant vector also. So I'm going to illustrate this with an example. So for example, after you solve a system, you have this. You have x1 equal to 5 plus 4x3. And then x2 is equal to negative 2 minus 7x3. Now, this system is not the homogeneous system. It's just any system, okay? So it could have some constant here. So x3 would be equal to x3 free, right? So the one that is free, I'm going to take it out. So I would write it as matrix in vector. I will write x1, x2, x3 as a vector. So this was not a vector, it's just a solution form. Now I'm going to write it as a vector, and whenever I have a free one, I pull it out, and I'll say what are the coefficient of x3 in all of them. So this is 4 and negative 7. And this one is free, so that means 1. And after this, I get rid of these. I still have a constant vector, so I say 5, negative 2, 0, because I don't have any constant here. So there I am writing this answer as a combination of a vector plus a constant. So it's a constant vector and then add another combination of a vector. Okay, so this is the solution. What about if after I solve a system, it's like this? So this most likely is a solution of a homogeneous system. Usually if you look at this in a homogeneous system, the right-hand side, even after you do row echelon, is still 0. So you don't expect any constant to show up in your solution. So let's write it vertically. x1 is equal to x2 plus x3. So it has two things. And then x2 is free. So you will say x2 free. So you keep it. x3 is free. So x3 free. x4 is negative 2 x3. That's it, right? So how would I write it in a vector form? I would write it as x1, x2, x3, x4 as a vector. And then which one is free? x2 is free. I pull it out. In some books, they actually pull the constant out first. So you can do that. x2, this one has x2, so I say 1 for x1. And then I have 1, of course, 0 for x3, and then no x2 also, right? Because the last one only has x3. And then I have x3, which is a free variable. x3 would be another 1, 0, 1, negative 2. And that's it. So the solution is a combination of two vectors, linear combination of any linear combination of this vector and this vector. Okay, so let's actually solve it. So suppose someone gives you a system, it is a homogeneous system. We got to solve it by writing the augmented matrix 1, 3, negative 5. And 1 for negative 8. Oopsie. And then negative 3, negative 7, 9, 0, 0, 0, right? So this is the augmented matrix. Do I have it? 1, 3, negative 5. Yeah, I have it. 1, 4, negative 8, negative 3, negative 7, 9. Is it? Negative 3, negative 7, 9. Yeah, so this is C. So I'm going to do a reduced echelon of C. What does it look like? Is copy down 1, 0, 4, 0, 0, 1, negative 3, 0, 0, 0, 0, 0. So it has some free column. So it's equal to 1, 0, 4, 0, 0, 1, negative 3, 0, 0, 0, 0, 0. So how do I write it? this is x1, right? So I have x3 is free. So we'll say x1 plus x plus 4x4, x3 is equal to 0. X2 minus x3 is equal to 0. X3 is free. And then write it in a vertical form, it will be x1, x2, x3. x1 is equal to negative 4, x3, x2 is equal to equal to 3x3. There's actually a 3 here. I left out the 3. Then x3 is just x3. So you can see I can just pull out the x3 and it happens in all of them. So I'll say x1, x2, x3 is actually just x3 times a vector, which is negative 3, negative 4, 3, and then 1. So it becomes just a line. In an R3 situation, this is a vector in the space, right? Somehow. And then you have any, because this is a free constant, you can just scalar multiply this, and it's just a line. So the solution of this equation is just a line. Meaning, also means if you do it in a combination, yeah, so it's just the solution. The solution can be described as a line in a vector space. Okay, so let's do more. So different way of writing those. In this case, we are doing homogeneous again, right? So it is a homogeneous ax equal to 0. A is really a big vector. It's like a big matrix. So I enter it here, 3, 0, negative 5, 5, negative 2, 0. Oh no, it's different one. 3, 0, negative 2, 5, negative 2. Yeah. And then 0, 1, yeah. And I enter the 0 on this side. So remember to enter your 0, 0 for an augmented matrix. Okay, so I'm going to just do a row echelon of A, right? And what happened? Oh gosh, it's really big. So be 1 and then 3, 0, and then a 4, and then a 0, 0, 1, and then a 0, negative 3, and then a 0, 0, 0, 1, and then a negative 4, and then a 0, and the last row is all 0. So let's copy it down. So this is solving ax equal to, so that means we would write it as, 3, 0, negative 2, 5, negative 2, just as a 0, right? 0, 0, 1, 0, negative 3, 0. That's what I entered earlier. 0, 0. So actually, even before the row echelon form, the last row is already a zeros. And then it become 1 and then 3, 0. 1, 2, 3. Then a 4, 0. 0, 0, 1, 0, negative 3, 0, 0, what? 0, 0, 0, 1, negative 4, 0, and then these are all 0, 2, 3. Okay, so how do I write it? So I would say x1. So this is a 0, right? So x1, x2, x3, x4, x5, I have 5. So plus 4x5 equal to 0. Then x3 minus 3x5 equal to 0. They only have x4. And then x4 minus 4x5 is also equal to 0. Which one is free? These three are the private columns, so x2 and x5 are free, right? x2, x5 free. So how do I write it as a matrix? I will write x1, 2, 3, 4, 5. Okay. And then x1 would be negative 4, x5. x2 is x2. x3 is negative 3, x5. X4 is negative 4, x5, and x5 is x5. So you can see that you can take out x2, and take out x5.